Hello, this is my first video, but I just wanted to pretty much share with you guys some golden information. So I've been programming in C for quite a long time, and basically today I just wanted to show you some ways that you can make your code more robust. So here is just a normal function right here that basically finds a number and returns its index from the array, and it's called find number, and that's what we want it to do. We want it to return an index in the array where it found num, and that's pretty simple. As you can see right here, I have it so that it returns -1 if it can't find it, and this is fine. I mean, you can program C in this way, but there's better ways of doing it if you want correctness, because I do think there are some good things to take from Rust's book. Now, there's a lot of bad things about Rust. Personally, I think, kind of like Cargo and the Rust Foundation, but there's really some good ideas that Rust has in just like the compiler, the language itself. So I think it would be good if C programmers could learn from that. So this is our original function, right? Now, to make this better, I included a standard definition file, and I changed size to actually be a size t, because you don't know how big the array is. The array could be bigger than what an int allows. So that was the first thing I did. Now, of course, if you compile this, you're going to get warnings about comparing I, which is an integer, against a size t. And of course, that's because ints and size t's aren't the same. They might be on your specific architecture, but on most architectures, they're not the same, and it's for good reason. You shouldn't code like that. So one way to fix that would, of course, be come over here and return a size t. Problem with that, though, is that you can't return -1 anymore, and you could, I guess, return like -1 like this, but it's not as obvious, and it would be very cumbersome because you'd have to define like cent and all up here, wrap it in parentheses, and then return that down here, which is fine, but there's a better way we can do this. So just for now, we're going back for a second. One thing I do want to say here is that you should make sure to make your intent clear to the compiler. Now, the compiler can probably guess and optimize without these consts in here, but with these consts in here, you're gonna have there's gonna be no way you're gonna accidentally, let's say, change num and find the wrong number. So it's just good habit, good practice. Again, something we can take from Rust. And we'll get to the size t thing in a little bit, which is the main point why I wanted to make this small helper video. So if we go to this one here, let me add the consts there and place that. I think numbers just makes it more readable. So as you can see here, we actually have something a little bit different that if you haven't been keeping up with C, you might not know what it is. Instead of a pointer for our array, we actually have this, which if you know what variable length arrays are, you might think it's a VLA, which thankfully it's not. You should never ever use VLAs in C. maybe there's one instance where you could use it and it would work okay, but usually it's too much of a black box, and we don't really like that in C. So as we do know, though, arrays decay into pointers, and that's pretty much the same concept here. This is an array. It's still going to decay to a pointer. It's still functionally identical to the pointer we had earlier, but again, we're giving more information to the compiler, and you're much more likely to not make as many errors with this. So let's just make this a little bit more simpler here. This is saying that we're taking in an array of numbers of an unknown length, which would be the same as, say, doing this, right? But if we come over here and do this, it's the same, right? If we put length in there, we're telling the compiler it's an array of numbers with a size of length. Now, it doesn't have to have a size of length, and this is, of course, because C doesn't want to put a lot of restrictions on things to keep the optimizations fast and for other things. But basically, we're saying it's an array of size of length. It doesn't have to be size of length, actually, but that's why we put static, which basically tells the compiler that it has to be size, an array of size of length. One thing that putting static there does for us is, hold up a sec. One thing putting that static there does for us is that because it has to be an array of size of length, we can't do something like pass null into here. We're going to see there's going to be an error. Null passed to callee that requires a non-null argument. That's because null would have a size of 0. This static means it has to have a size of length. If we remove that, you can see the error goes away. Last thing here is const, which means that basically it means the array of numbers is constant. Not the individual elements of numbers, but the array itself is constant. So we can't do something like this. We can't set the pointer for the numbers array to something else because it's a constant array. It's the same as saying that. So that's the newer way of doing it. And then this is where something else comes in. So if you remember earlier, if we compile, we're going to get a warning here that I is an integer and length is a size t, and we're doing a comparison between each other. And you can remember back to the talk about the awkward sentinel definition. One way that I learned about recently that I think is a really elegant way to fix this is, okay, it's not there, is just by defining the structure right within the function. So if we have a structure here, we can define the size t as the index, and we can also have a boolean for whether or not it's been found. And that's pretty simple. Here we define the structure, and then normally with a structure, you can do, normally with a structure you can like define a variable for the structure right after it. This would just be a file scope variable bar. But in this case, instead of putting a variable name after it, we put a function after it, making struct find number the return. Now, sadly, I don't think this works, but I'd have to try it. I think it would look something like this. But I don't really think that works. Still have to try it. I'll add something to the end of the video telling you whether or not it does work. But another good thing about this is that you can use this syntax. I don't remember what it's called, But you can use this syntax, and then in here you can use the dot syntax for every field, and that's a lot better because I can, maybe it's more optimized if I move these two around like this or like this, and it won't break if I do that. And if I undo, it's not too hard to make a forward declaration of this. You just do the same thing as before, but then when you go to the definition, you just do struct find number. Pretty simple. So I'll be right back when I figure out if you could do type defs or not. But yeah, this is kind of just a small tidbit of information that I wanted to share with you guys to make your code more clean and less bug prone. So have a good one.